In this video series, we're going to be examining how to solve absolute value equations. Now, the most basic definition for absolute value is it represents the distance of a value or an expression from zero on the number line. We're going to be focusing a lot on expression in this lesson. Now, what does this mean in context to what we're going to be dealing with? Now, since we're dealing with distance, distance can only be positive, and that's going to be really crucial in this lesson. When you take the absolute value of a number or a variable expression, it should be positive, excluding if you're taking the absolute value of 0, because the absolute value of 0 is 0. If we look at this, the absolute value of x equals 6, then that means x is 6 or negative 6. But what does this mean in context to our definition? Let's apply the idea to the definition. So here's a number line. In the middle, I have the number 0. The absolute value of x equals 6 means the distance of x on the number line is 6 units from 0. So that means x is located to the right 6 units and x is located to the left 6 units. So that's why x equals 6 or negative 6, is because I can go distance 6 units to the right and a distance of 6 units to the left on the number line. That's why an absolute value equation splits into two regular equations. If I have x plus 2, taking the absolute value of that expression, the absolute value of x plus 2 equals 5. I can split it into two simpler equations. X plus 2 equals 5, x plus 2 equals negative 5. Again, in context to the definition. Read the problem in context to the definition. X plus 2, the absolute value of that expression, the absolute value of x plus 2 equals 5. That means the distance of that expression, x plus 2, is 5 units from 0 on the number line. So x plus 2, go to the right 5 units. That means x plus 2 equals 5. I could also go to the left 5 units, and there's negative 5. So x plus 2 could also be located here. So x plus 2 equals negative 5. And that's where we get our two equations from, is we're looking at the distance to the right side and the distance to the left side of 0. Notice, and this is extremely important, the signs of the expression in the absolute value bars do not change. Only the number outside changes from it. We didn't change anything inside because we're looking at the distance of that object. And so the x plus 2 stays the entire time. It's the 5 that's going to change to a 5 and negative 5 from it. So when we are now solving absolute value equations, let's keep the following ideas in our minds. First, get the object by itself. Isolate the absolute value by getting rid of any operations occurring on the outside of it. That means you might have to remove some constants that are outside the absolute value bars. You might have to get rid of any coefficients for the absolute value bars. After the absolute value is completely isolated, then split it into the two equations. One where it's equal to the positive of the expression and one where it's equal to the negative of the expression. Then solve, and here's the part, and I explained this in the previous video, you have to check your answer. There may be times where you do everything right mathematically, and here's what occurs. You do everything right mathematically, and you get an answer for x, you plug it in, and it yields a statement that is false. It is important. This is no longer optional for the rest of Algebra 2, is you now have to check every single answer, because we're going to find out in this video series that we have some answers that algebraically we did everything right, but when you plug them in, it gives us the wrong answer. And those are called extraneous solutions. And those will be popping up a lot from this point on in the school year. So understand this concept of absolute value equations and why we split it into two equations in order to solve before you move on to